Hello everybody, I'm your host Hal Curtis and I'd like to welcome you to The Space Industry by satsearch, where we share stories about the companies taking us into orbit. In this podcast, we delve into the opinions and expertise of the people behind the commercial space organisations of today who could become the household names of tomorrow. Before we get started with the episode, remember you can find out more information about the suppliers, products and innovations that are mentioned in this discussion on the global marketplace for space at satsearch.com. Hello everyone and welcome to the episode. Today I'm joined by Lucille Baudet from Oxford Space Systems. Oxford Space Systems is a manufacturer based in the UK who provides deployable antennas for the space sector. And today we're going to be discussing a little bit about the challenges of creating deployable antennas and systems for CubeSat missions. Lucille, thank you very much for being with us today. We're very pleased to have you. And is there anything else you'd like to add to that introduction?
No, thank you. That's a very good introduction and thank you for having me today.
Right, so let's get into this topic. Now, when it comes to deployable antennas, I think the word origami sometimes comes to mind. Could you provide an overview of how the need for deployable antennas on small spacecraft has emerged over the last few years and what advantages they can bring to legacy solutions that maybe people are more familiar with?
I will say as a brief overview, we can say that over the last few years, we have seen the size of satellites decreasing significantly. And this has actually enabled the possibility to get into orbit at a much lower price. And this is particularly true in the LEO environment, in the low Earth orbit. The thing is, given their low cost and launch opportunities, CubeSat technologies has opened up the possibility to deploy a large number of satellites as part of what we call constellation. And I guess many of you are familiar with constellation. And if you look at reports like Euroconsult, they are predicting that over the next 10 years, commercial constellation will account for 70% of the satellite being launched. However, even if the satellites tend to get smaller, their need for performance doesn't get smaller. So it's still have to perform the same level, and if not actually to have higher performance than traditional larger satellites. So then the issue with existing solution is they tend to be quite large. So they won't fit anymore in the required size and volume given by the CubeSat technology. So then the only possibility is to use deployability. So what we use in Oxford Space System is techniques inspired by origami, so that you can create antenna that you can fold in a small and compact volume for the launch phase under the rockets, right? And then once the satellite is in orbit, it deployed and then create a larger structures. So this is where the need for deployable antennas came from, where you have this challenge of fitting a small antenna in a small and compact volume given by the CubeSat technology.
You mentioned there's still a requirement for the high performance in the missions that use deployable systems. From a performance standpoint, how do deployable antennas compare with legacy systems?
Yeah, so there is no straightforward answer to this question, actually. So because being able to fit a deployable antenna within a 1U volume, and when I mean 1U is 10 by 10 by 10 centimeters, it does come with challenges. We are using actually a combination and a set of skills between RF, mechanics, and materials to address these challenges. In that regard, it's quite hard to compare the performance towards current solution. And when I guess you mean legacy solution, I mean fixed rigid antenna, right? So it's kind of hard to compare directly because there is always a trade-off to be made, a trade-off between important characteristics with RF performance, mass budget, but also the volume available on the spacecraft itself. So based on all these parameters and the information that we collect from the customer requirements, we have a technical excellence team who can quickly perform a trade-off analysis and then assess the level of performance that can be achieved with a deployable antenna. But I would say it can be kind of a case-by-case basis, right? And because there is all these parameters to be considered, it's quite hard to compare directly to a legacy solution. There is no single point of comparison when we talk about performance.
Well, if we turn to maybe applications then of deployable antennas, what kind of use cases do you see being enabled by the technology, and what advantages to service providers would be brought by, the ability to stow and then deploy different antenna configurations on a small satellite or spacecraft?
Yeah, so as I was mentioning at the very beginning, I was mentioning about the emergence of small sat constellation, which is going to be a major driver of the satellite industry and actually right now concentrate a large share of the satellite demands. And the thing is they are bringing a new rationale where you launch a large number of satellites at a lower cost, but also with a shorter lifetime. So the move to SmallSat constellation actually enable new application on the market, new applications such as Internet of Things, but also maritime surveillance and tracking. You might have heard about AIS mission, which stands for Automatic Identification System, which is for basically tracking ships in the sea. And this type of mission are usually part of commercial constellation and require fast deployment into orbit because they want to generate fast revenues by providing data as a service. So actually our solution, our CubeSat deployable antenna solution, are able to offer very cost-effective products to fit this constellation needs and actually optimize also for batch production, which is a real added value for our customer who wish to deliver services as part of constellation.
Yeah, that makes a lot of sense. I think we've got those applications, interested applications like maritime tracking, where the need already exists. You don't have to build anything on the ground in order to generate value and revenue from the satellites that are launched. So yeah, that's interesting there. So, but obviously the systems can only be deemed a commercial success if the reliability is there and if the performance can be not guaranteed, but at least tested and qualified. Now, deployables are always tricky because a failure to actuate could be a single point of failure for the satellite as a whole. How do you ensure reliability? Are there any examples, where you can provide on deployment process or once the spacecraft is injected based on some of the missions that you've worked on at Oxford Space Systems?
This is actually a very good question. And this is usually one of the first questions we are being asked by our customers because reliability is one of the most important criteria, as once you send your satellite into orbit, you don't have any second chance, right? You cannot send a service engineer to repair and fix your issues. So reliability is very important and critical. And if I will need to mention our process, so in terms of process, there is kind of a balance to be made between quality, cost, and risk appetite. And because, if you have an extensive development and testing campaign, this can drive the cost up. And the thing is, our approach with our antenna solution and the associated deployment system are quite being made simple on purpose so that you kind of remove a bit this risk. And we're also using flight-proven materials and design to really reduce any risk of failure during deployments. And we want also to be consistent with the simplicity of the CubeSat technology. So we're kind of following a structured process with a high level of mechanical and RF design analysis, which then is being followed by a testing campaign so that we can ensure right level of test and reliability to our customer. And as an example, what we can say is, as of today, we have flight heritage on our helical antenna product line, having 3 of them currently flying, successfully deployed, and supporting the commissioning on the IoT constellation. And actually, having flight heritage is now providing even more reliability to our customer because it's now flight proven, it's currently flying into orbit, and we have now currently a number of repeat build orders in a pipeline from various customers.
We've so far discussed aspects of the applications and the trade-offs involved in the technology. I wondered if we could talk a little bit about the kind of the state of the art or maybe even the future, particularly with the materials, because I think deployable systems, antennas and other forms of deployable systems, the materials that are used to create them, a lot of work, I'm assuming, goes into them because, these systems need to deploy and need to operate externally to the spacecraft with their own radiation shielding and everything that goes with that. So where do you see, current progress in new materials or other advances in technology that could be applicable to the sorts of technologies that you create at Oxford Space Systems?
Yes, material is quite an important component because I was mentioning we are using a combination of skills between RF, mechanical, but also with material we are using. So exploring new materials is therefore an important component of our solution, but also always part of our research and development roadmap. As an example, I could say that we are using metal mesh knitted from a very fine tungsten wire, which is a very lightweight material, providing high RF performances, high reflectivity properties for the surface of our antenna that we are using for several of our antenna architecture. And establish a new metal mesh facility with our own knitting machine in our facilities in Howell. So it's quite, people are always surprised when there is visitor coming. They're always surprised, like, to see a knitting machine. It's not something you expect to see in a factoring of antennas. But yeah, this is the material that we use, and it's very important because it just provides the right level of performance. And the first application of this metal mesh produced at Howell will be for a synthetic aperture radar antenna, which is called a RAP-RIB antenna, which is targeted for launch in late 2022.
Right, brilliant. You're really looking forward to the future with some of the work being done on materials there. So, and I guess that leads into my next question and final question. Just to put you on the spot a little bit, I wonder where you saw the market heading for deployable antennas or deployable systems in general in the next 3 to 5 years. If we look beyond the horizon of missions planned today, are there any specific segments or types of antennas that you see as gaining more traction over competing systems?
Yeah, so at the moment, as I was saying before, in terms of CubeSat missions, we see a high demand and development for IoT applications, so Internet of Things application and AIS, FIDES missions. So these are markets that have been growing a lot recently. And again, if you look at Euroconsult and reports, they will say that there is more than 30 projects and potential constellation being announced. This type of market are really growing. And having satellites, being launched in constellation actually enables distributed data collection, and which has the development of new applications such as communication, remote sensing, as well as science and exploration. But now just moving a bit broader than focusing on CubeSat and going at small sat solution with satellite a bit more than 50 kilo. We have, as I was mentioning, our RAP-RIB antenna and also another architecture called offset reflector that both capable of providing performance for SAR application, for Earth observation application. And the offset reflector can actually be scalable and provide higher frequency suitable for telecommunication. But we are actually exploring potential solution for 5G and also inter-satellite links, because the reason behind we have seen a number of requests coming for customer for this type of application over the last few months. So this is something we are currently looking at. And yeah, last point I would like to make as well is we are doing a lot of early stage R&D work to adapt actually also our deployable antenna to terrestrial application as well. There is also actually a kind of a niche market for terrestrial application, more in the defense and security application. So yeah, in summary, I think deployable antennas can be really a game changer in many markets. And at Hotfox Space System, we really aim to really keep innovating and be creative to enable our customer to deliver really exciting new services and mission, but staying in the affordable satellite technology.
Right, that's a great place to wrap up. I think there's a really wide range of different application areas there. That's some really exciting, interesting work that you guys are doing. Yeah, thanks very much, Lucille. It's been really interesting to learn about the use cases and trade-offs of deployables, the testing requirements, advanced materials, and so on. Thank you very much for spending time with us today on the Space Industry Podcast.
Thank you very much.
Great. And for all our listeners out there, remember you can find out more about Oxford Space Systems and the whole portfolio of technologies and services discussed in today's episode on the satsearch platform at satsearch.com. You can also use our free request system to make requests for technical documentation, quotes, introductions to the company, or whatever else you might need for trade studies, procurement purposes, and anything else required to develop your missions. Thank you for listening to this episode of The Space Industry by SatSearch. I hope you enjoyed today's story about one of the companies taking us into orbit. We'll be back soon with more in-depth, behind-the-scenes insights from private space businesses. In the meantime, you can go to satsearch.com for more information on the space industry today, or find us on social media if you have any questions or comments. To stay up to date, please subscribe to our weekly newsletter, and you can also get each podcast on demand on iTunes, Spotify, the Google Play Store, or whichever podcast service you typically use.